Impact of food toxins on ADHD. Attention deficit or hyperactivity disorder, ADHD, is a common neurodevelopmental disorder characterized by inattention, hyperactivity, and impulsivity. The rising prevalence of ADHD has prompted extensive research into its causes, including the potential role of food toxins. Food additives and heavy metals are particularly concerning due to their effects on brain function and behavior. Understanding how these toxins influence ADHD can help in developing strategies to mitigate their impact and improve overall health and well-being. Effects of food additives on ADHD. Food additives, including artificial colors, preservatives, and flavor enhancers, are widely used in processed foods. These additives have been implicated in the exacerbation of ADHD symptoms. Studies have shown that certain artificial colors and preservatives can increase hyperactivity and inattention in children. One of the most well-studied groups of food additives in relation to ADHD is artificial food coloring. Synthetic dyes such as red number 40, yellow number 5, and blue number 1 have been linked to behavioral changes in children. A landmark study published in The Lancet found that children who consumed a mixture of artificial colors and the preservative sodium benzoate exhibited increased hyperactivity compared to those who did not consume these additives. These findings have led to regulatory changes in some countries, where warnings are now required on foods containing these dyes. Monosodium glutamate, MSG, a common flavor enhancer, has also been associated with behavioral issues. MSG can cause excitotoxicity, where nerve cells are damaged or killed by excessive stimulation, potentially leading to symptoms such as hyperactivity and inattention. Effects of heavy metals on ADHD. Heavy metals like lead, mercury, and arsenic are pervasive environmental pollutants that can contaminate food and water supplies. These metals are neurotoxic and can interfere with normal brain development and function, contributing to ADHD. Lead exposure, even at low levels, is a well-documented risk factor for ADHD. Lead can cross the blood-brain barrier and accumulate in the brain, disrupting neurotransmitter systems and reducing cognitive function. Children with higher blood lead levels are more likely to exhibit symptoms of ADHD, including difficulties with attention and impulse control. The Centers for Disease Control and Prevention, CDC, has identified lead exposure as a significant public health concern, particularly for children living in older housing with lead-based paint. Mercury, particularly in the form of methylmercury found in contaminated fish, can also affect brain development. Prenatal and early childhood exposure to mercury has been associated with cognitive deficits and behavioral problems, including an increased risk of ADHD. Mercury disrupts neuronal growth and synapse formation, which are critical for attention and behavior regulation. Arsenic, commonly found in contaminated water and certain foods, can cause neurodevelopmental delays and cognitive impairments. Studies have shown that children exposed to higher levels of arsenic are at greater risk for ADHD and other behavioral issues. Behavioral implications of toxin exposure. Exposure to food toxins, such as additives and heavy metals, can have significant behavioral implications, particularly for children with ADHD. These toxins can disrupt neurotransmitter function, alter brain structure, and impair cognitive processes, leading to increased hyperactivity, inattention, and impulsivity. The behavioral effects of toxin exposure are particularly concerning during critical periods of brain development, such as prenatal and early childhood stages. During these times, the brain is highly sensitive to environmental influences, and exposure to harmful substances can have long-lasting effects on behavior and cognitive function. Mitigating the impact of food toxins on ADHD. Reducing the impact of food toxins on ADHD involves both regulatory measures and individual actions. Regulatory agencies need to enforce stricter limits on the use of harmful food additives and monitor environmental contaminants to ensure safer food and water supplies. Promoting the use of natural alternatives to artificial colors and preservatives can also help reduce exposure. individuals can take proactive steps to minimize their exposure to food toxins. Choosing organic and whole foods, reading ingredient labels, and avoiding products with artificial additives can help reduce the intake of harmful substances. Ensuring clean drinking water and minimizing consumption of high-mercury fish are also important measures. Public education campaigns are essential to raise awareness about the risks associated with food toxins and to encourage healthier dietary choices. By understanding the sources and effects of these toxins, parents and caregivers can make informed decisions that protect their children's health and well-being. Conclusion: food toxins, such as additives and heavy metals, play a significant role in the development and exacerbation of ADHD. Understanding these impacts and taking preventive measures can significantly improve behavioral outcomes and overall well-being. By addressing environmental pollutants and promoting safer dietary practices, we can protect public health and reduce the burden of ADHD.